Now we'll look at Descartes Rule of Signs. Descartes Rule of Signs, if we let f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a sub 1 x plus a sub 0 be a polynomial function with real coefficients, the number of positive real zeros is either equal to the number of sign changes of f of x or is less than this by the number of sign changes by an even integer. Meaning if it changed 3 times, it could be 3 or go down by 2, an even integer to 1. The number of negative real zeros is either equal to the number of sign changes of f of negative x or is less than that number of sign changes by an even integer. So again, if you plug in negative x and you get, look at your sign changes, if there were 4, then it could be 4, it could be 2, it could be 0. So the easier thing is if there's odd, you know you're going to have at least one of that type. So use Descartes' rule of signs to determine the possible number of positive and negative real zeros for this polynomial. So right now as we see it, it's negative, negative, then it goes to positive, that's one change, then it goes negative, that's 2 changes. So this is how I like to do my tables. And this is probably not the way everyone does theirs. Like, I don't know if our book does it like this, but I saw 2 sign changes. Now, if we look at f of negative x, that's going to be the negative of x to the negative x to the 4th, minus 3 times negative x cubed, plus 6 times negative x squared, minus 4 times negative x, I got out of space here, and then we'd have minus 12. So let me summarize that. That's f of negative x is going to be negative x to the 4th. We have now a double negative. This 3 should be on here. I'm sure that someone was probably screaming at their screen. Anyway, negative x cubed is still negative of x cubed, and then that'll give us a double negative. So we have plus 3x cubed. Negative x, that quantity squared, will just be positive x squared, so plus 6x squared. Then we have minus 4 times negative x is plus 4x minus 12. So here we're seeing 1 sign change to 2 sign changes. That's over there. So we could have 2 negatives, so 2 positive, 2 negatives, and 0 complex. By the way, I want to point out 2 plus 2 is 4. Now, the positive can go down by 2, so there could be 0 positive, 2 negative, and then 2 complex. So let's see, these 2 that were here could have been complex. Or we give 2 positive, 0 negative, and 2 complex. Or, check this case out, 0 positive, 0 negative, and 4 complex. Wouldn't that be a fun one to work with? So, okay, that's how we use Descartes' rule of signs.